Hey, hello and welcome to today's GFG problem. Today, I hope you're doing well. So let's say today's problem, maximum index. So we will be given an array. Okay, we'll be given an array, and what we want to find is maximum distance. That is maximum of j minus I. Right? We want to find this, right? And what is j and I? So what are the conditions for this? Right? So the conditions are a of j should be greater than or equal to a of I. Right? This a of j and j, the position j. This is a position j has to be greater than or equal to I. Okay, for these two conditions, right? For these two conditions, having these two conditions, we have to find the max of j minus I. Okay, so here if you see in this particular example, what is the maximum distance? Maximum distance, right? Maximum distance is 6. How? So it is chosen this one, right? I, this is the I, when this is I, and when this is the j, right? When this is the j, then for example, what is it satisfying this condition? A of j. A of j is 33. Yes, it is satisfying, right? A of j 33, it is greater than a of I 8, right? And j, this j is also greater than I, right? And this is the maximum j minus I which we have. So we want to return this, right? Maximum distance, right? Says that it satisfies these two conditions. So yes, so this is the problem. Okay, now how to solve this problem? How to solve this problem? So the first brute force or naive approach would be what would it be, right? What it would be O of n square, for example. For we'll have a loop, right? Int I equal to 0 to n, right? And for int j equal to I to n, right? And then we can have the maximum answer equal to, for example, it will be initialized with minimum sum, right? And then we can find out the maximum, right? So this approach will take O of n square. This approach will take O of n square, but the expected time complexity is O of n, right? So we want to optimize this further, right? So how can we solve this? Okay. So one approach is, let's see what that approach will be. What we'll do is, as we want to, so this is the j and this is I, right? So in order to make it maximum, so j needs to maximum as possible, and I needs to be as minimum as possible. Then only we'll get the maximum, right? Yeah. So what we'll do for for this particular part, what we'll have is prefix minimum array. Okay. For example, left min. Let's see what is prefix minimum. So what it will be? It will be the as I said, right, prefix minimum array. For example, what it will be, let's say, so the formula will be, so this will have a left minimum array, right? And what will be the formula? Left min of I, right, equal to min of left min of I minus 1. That is the left one. And the current A of I. What is the array? Okay. So for example, this will be as is 34, right? This will be as is. Now if we compare between these two, what the minimum is 8, right? 8. We got 8 here. Then now what we're going to do, we're going to compare this and this, right? This 10 and 8, right? A of I. A of I, we're comparing minimum and left min of I minus 1. That is the previous one, right? Previous, yeah. So 8, 10. What is minimum? 8, right? Then we'll come here, we'll compare this and this. 3, A of I, and this, left min of I minus 1. And it is 3, right? Here, if we compare this and this is minimum, so this will come 2. Now, this and this will compare, right? So this is minimum, we'll write 2. This and this will compare, this is minimum, we'll write 2. This and this will compare, this will write minimum 2. This and this will compare, this will come minimum 1, right? So this is a left minimum array. That is a prefix minimum array, right? The minimum from the left, the minimum elements on the left. Now what we'll do for this j, right? At it needs to be maximum, we'll have a right max array. That is a suffix maximum array we'll have, right? So how we'll fill that? How we'll fill this? For example, right? What we'll have a one here, we'll store as it is, right? Now the formula would be right max, and this is another array, right? Right max I equal to max of right max I plus 1, and comparison will be with a of I, right? So here one will come as is, right? Now what we'll do, we'll compare 33 and this one, right? For maximum, right? Right of I plus 1, right of I plus 1, that is this for this position, right? Right of I plus 1 is this. And what is A of I? A of I is 33, right? So 33 and 1, what is maximum? 33 is maximum. Then 33, sorry, 33. Then 30 and this one, comparison, 33 is maximum. Sorry, let's write properly. 33 is maximum again. Then 80 and 33, what is maximum? 80 is maximum, right? 2 and 80, what is maximum? 80 is maximum. 3 and 80, what is maximum? 80 is maximum, right? 10 and 80 comparison, again 80 is maximum. 8 and 80 comparison, 80 is maximum. 34 and 80 comparison, what is maximum? 80 is maximum, right? It is maximum. Yes. Now, so we have two arrays, prefix minimum array and suffix maximum array, right? So we have these two arrays, right? We have these two arrays. Now what we are going to do is, we are going to have 2 pointers, I, right? I and j, right? J is for the maximum, right? We want maximum, and I want minimum. So what we are going to do is, we are going to initialize with 0, right? We'll start from 0 and we'll compare, right? If 34, we'll have an answer variable. Answer will be initially -1, right? Now we'll compare I and j, right? Left min of I and right min of j will compare. Right max of j, right? Will compare. If right max of j is greater than greater than this left minimum, greater than equal to left minimum, then yes, we have found our first answer. So what we're going to compare, answer equal to max of answer, comma, what? J minus I, right? J minus I. We are going to check if right max of J is greater than left minimum of I, right? If it is, then do this, right? J minus I. What is J? J is 0, I is 0, right? 0 minus 0, and answer is, as it is, minus 1. So now answer will be what? Answer will be, initially it was minus 1, now it is 0. Okay, 0. Now what we'll do, now if this right max of J was greater, right, with left minimum of I, then we will going to increment J, as we want to maximize J, right? We want to maximize J, so we are going to go to the right. We are going to go to the right, right? So we went right. Now we'll compare again 34 and 80, right? So right max of J is still greater than left minimum of I, right? Left minimum of I. So what we are going to do, we are going to update answer again. We are going to update answer again. Answer, comma, J minus I. What is J? 1 minus I, 0, right? So 1. So answer will be 1. Now J minus I, 1 minus 0. Again, as this was greater, we'll move J. We want to maximize J, right? We want to maximize J. So we are moving J to the right. Now J is 2 and I is still 0. So we'll compare again. Right max of J is greater than still left minimum of J, right? Left minimum of I, right? So yes, it is greater. Then we are again going to update answer, right? Now answer J is 2 and I is 0, right? So we are going to update answer, right? And we'll move ahead again to J. So J is still greater than I. J, right max of J is still greater than left minimum of I, right? So again, we'll update answer. Answer will be 3. Again, we'll move ahead where we were, 0, 1, 2, 3. Again, we'll move ahead. Again, we'll check. Okay, it is still greater. We'll update the answer. We'll move ahead. J, again, it is greater than this. Then we are going to update the answer, right? Now J comes here. J comes here. Now here, left minimum of I is now right max of J. Right max of J is less than, it is not greater than. It is not greater than left minimum of I. It is not greater than left minimum of I, right? So in this case, we are going to move I ahead, because this J, the element J is still is now no longer bigger. Okay, so we'll update I now. Okay, now we'll compare again. 33. Yes, what is J? J is what? J is 7, right? J is 7. J is here, right? And I is here. So we'll check. 7 minus 1, right? 7. J is 7 and I is 1. 6. So yes, it is greater than answer. So we'll update the answer, right? Now again, we'll check here. If we'll move at J, now and we'll check if J, right max of J is greater than this. No, it is not. So we are going to increment I, right? We are going to increment I. Again, we are going to check if right max of J, no, it is still not. So we're going to increment I. Again, we'll check, no, it is still not. We're going to increment I. We'll keep on incrementing I, right? We'll keep on incrementing I, right? Because this right max of J is lower than left minimum of I. So we'll keep on going and then we'll exhaust basically, right? So this is the approach. This is the intuition. I hope you've got the intuition. So if you've got the intuition, I would request you to subscribe to my channel before going to the code. So I'm going to implement the Java code and then I'll show you the C++ code. Okay. Now first, the basic condition is if n is just 1, right? In this case, we're going to return 0 simply. Now then what we're going to do, as I said, we are going to have left minimum, right? New int n. We are going to have prefix minimum array, right? And suffix maximum array, right? Max. We can maybe name it as like this, max and min, right? And then what we're going to do. So first, let's first fill up the left minimum array. So for the first element, it is going to be same, right? This left minimum, it is going to be the same, 34, 34, right? In the left minimum, it is 34 only, right? So 0 equal to a of 0. Now what we're going to do, how we're going to fill? We'll start with I equal to 1, right? I less than n plus I, right? Plus I. Then what we're going to do? Left minimum of I, right? Equal to math.min, right? So it is relatable, quite relatable even for C++ guys, okay? So left min of I minus 1, right? The previous left min or current air of I, right? So whichever is minimum, this left minimum of I will have that, right? So this is the left minimum array. Now let's fill up the right max array. So the last element will be as is, right? This last element will be as is, 1 and 1, right? 1 and 1. So n minus 1 equal to air of n minus 1, right? And this array will start with I equal to n minus 2. 0, minus, 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 right? Then what will have, right? Max of I equal to math dot max, right? Max of I plus 1, the next element, and a of I, this way, right? This way. Okay, so we have this left minimum and right max arrays, right? Now what we're going to do, we are going to have two pointers, right? Int I equal to 0, j equal to 0, and both will have this in the while loop. Both has to be less than n definitely. And what we're going to check, if left min of I is less than right max of j. So we will put this condition later on. But if right max of j is greater, right max of j is, for example, right max of j is greater than left minimum of I, then we are going to move j and we are also going to update the answer as well, right? So first let's have answer as well, right? Int answer equal to max, let's say -1, right? So what we're going to do, yes, so we have found right max of j greater than left minimum of I. So we are going to update the answer as well. Math dot max answer comma j minus I, right? We want to find the distance, right? Maximum distance. And we're going to increment j to check again. To check again if this time right max again, if it is greater than j, right? It is greater than j, it is greater than left minimum of I. If it is not the case, we are going to increment I as I've already told, right? So in this way, we are going to calculate the answer and return the answer. Okay. So let's compile and run. So this gives us a time complexity of O of n, right? And okay, here there's some problem. What is the problem here? Mat dot max j minus I, j equal to 0, I plus 1, mat dot max. What is the issue? Why it didn't get updated? Answer mat dot max j minus I less than n, j less than n. Everything seems good. J minus I. Mm, oh, sorry. If left min of I is greater than right max of j, then we have to increment I. If right max is greater, right? So this will be executed, right? This will be executed, and we have to move ahead j, right? So let's compile. So yeah, let's submit it. Yes, all the test cases have been processed successfully. Let's quickly see the C++ code as well. The logic is same, definitely. So I have explained this. So here we are having right max of n and left minimum of I, n, right? And what you're doing? Here what we're doing? Yeah, we are doing the same thing. You know this. We have already explained this. Here only the thing is difference is we are taking vector OE, right? And rest everything is same. Here only we have max definitely, right? And max difference, right? So yes. So this is the solution. I hope you have got the solution. Please subscribe to my channel and like the video and have a happy, healthy, and a great day. Thank you so much.